Well, first of all, again, you see the embryonic cyclical behavior that in solving for the steady state. The original growth rate was around 3-point-something%. You'll see that this increase in government spending as a percentage of GDP increases the growth rate up to about 7.9%. It's quite a large increase in government spending, and it works. Notice that there's no reversion to any natural rate of growth or anything like that. This is a new steady state of the model, right? The model moves to a new steady state. And as I say, the stability is ensured by the informed monetary policy that the central bank of this world is conducting. Now inflation does go up. Okay, that would be the downside, shall we say. Doesn't go up all that much. It was around 4% before. It ends up at about 6%. Okay. The crucial thing to note here is that this is not ever accelerating inflation, right? The inflation rate settles down to a new steady state level. It doesn't go on and on forever. Now, the main argument of the neoclassical school has been, around the Phillips curve type argument, that if you try to boost growth by government spending, inflation will take off unsustainably. That's not the case. Again, assuming this stabilizing behavior on the part of the central bank. So that's the point that I want to note. Effect on real interest rate of an increase in government spending. Well, the ISLM model, you can throw it out. You can throw out the real business cycle model. You can throw out all models which predict that there would be an increase in real interest rates when there's government spending. The reason I want to do interest rates first is because of this well-known ISLM model, which where you increase government spending, the interest rate goes up. Well, the very opposite happens. Now, we all know that the very opposite happens in the real world. In World War II, government spending massively increases and interest rates fall. In recent history, there's been, in the United States, a massive, increase in government spending, massive increase in debt, and interest rates are at their all-time lows. So there's something wrong with the ISLM model, which we've known for a long time. This explicitly says that interest rates will fall, the real interest rate will fall. The reason that it occurs, of course, is we've already seen that this Keynesian increase in spending causes an increase in inflation. And there's a negative relationship, the Mundell-Tobin effect, as it's called, or the forced savings effect between inflation and real interest. Back to the profit markup. Now, the profit markup goes down as well. Okay, so there's going to be a question. You need to have the mic though.
Is there a level of government spending at which a further increase will not result in a further increase in growth?
No, not in this model. No. No. Obviously, you're worried about, are we going to have like 100% and so on and so forth. When we get more deeply into the model, you'll see that, the combination of spending and taxes. I mean, it's interesting to me that one of the things that does occur here is the profit markup falls. It was, 16 or 16-point-something% before, the aggregate markup. Now it's down to just under 15%, but it goes down. Also, this doesn't, in any light, foretell the end of capitalism. There's still there's still a 15% markup here, but it might provide an explanation as to why not everyone is universally happy with, an increase in government spending. I think we've done it all. So I'm going to turn it over to you now, Frederick, and you're going to do. I guess you're going to go back to your. Oh, yeah. Oh, sorry. Yeah.
Yeah. So sorry, maybe a very mainstream question, but How do you respond to the Lucas critique and saying that when you increase J, you somehow change behavior of people in the economy, so that maybe the relationship changed? So
I mean, the short answer is the ontology of the social world is different. If you wanted to really put it in mainstream terms, I mean, the key to Lucas's result is not only that result that you suggested, but also the fact that it was a model of perfect competition, which moves automatically to an equilibrium. As we will see later in the course, the underlying premise of this is, again, what a mainstream economist would call imperfect competition, right? So there's no going against their interests and so forth. They're responding rationally to their interests, if you want to put it in that way. I'm going to turn it over to you now, Frederick.
I think when they're discussing who's being right and who's being wrong, what I really want to know is, can we make money from this? A little bit of background about me. My name's Frederick. I graduated here in U of T. Then I went to York to do a master there. Then afterwards, I went to do a master in business in Queens. And I got my MBA in Japan. I know that's a lot of history. So having that business background, I tend to look things beyond theory. I tend to look on the application side of it. Can I make money from this model? Does it make sense? Or can I turn that theory into application with some kind of a value added that I input? And with AMM, I find that very, very easy. And to be honest, my previous boss that I work with told me this. The reason I hire you, because you can somehow turn in all your school knowledge into application and start helping me making money. Then I think what I told her is that, I'm not really good at doing that, but there are some models that are just so easy to turn into application than the other ones. And I think AMM is one of them. That's why I want to be part of it, and that's why I'm here. So here my interpretation of the model. As you'll know, I was like one of you back 2 years ago. I was a student in this class. Then I started to develop the same model with John. Then I started to have my own interpretation of it. And one of the interpretation I have is it's very complete. It captures all of the human behavior models, all the little tiny details about the economy. For example, what we see here. So here is animal spirit factor, which are here. Also the liquidity preference, which are here. You might ask, increase in liquidity preference might be, so people want liquidity, which means they want cash, which means they don't want to make any more investments. So with the Keynesian model, you might be saying, oh, that's a decrease in investments. Well, true in some extent. Well, but the magnitude is different. These are two very different factors here, which we'll discuss later on. So that's the human behavior factor, the E0 and P0 there. Also, the second one we have is the K, W, and R. These are the wealth distribution in the economy. K is the profit, how much money business is making. If K goes up, business happy. K goes down, business not happy. They want to make more money, of course. And W is a wage. What is the money that you and me are making as part of the business, I think. Again, W goes up, we're happy. If not, we're not happy. And R is the real interest rate, but the profit is here, M0. But this one's correlated to that one just because if the P goes up, R goes down, and the inflation overrides whatever the bank is making. So I think those three factors really capture the essence of the economy. See who's gaining and who's losing, and we can use those factors easily to evaluate some of the politicians' agenda or politicians' policies, for example. So yeah, beneficiaries are very transparent. And it's also very realistic. Instead of being garbage in, garbage out, we have treasures in, treasures out. I hope that makes sense. We're using real economic values. As we see here, those numbers are not always, not out of nowhere. There's no black box here. Anything can be researched. Anything can be Googled even. For example, the 03 is solely based on a research.
Yes, so just a short question. You're saying everything can research, and animal spirits is obviously a very complex phenomenon. So how do you simply say animal spirit, that's one number? And maybe I can Google animal spirits, but I don't think it will tell me a number.
Can I answer? I mean, don't forget we have to solve the equilibrium model, right? So there are some models which some numbers in there which are real numbers, government expenditure as a percentage of GDP, etc. Labor productivity. We'll discuss how that's calculated at another time. There are some which are relate to psychological variables. Animal spirits would be one. Liquidity preference would be another. There are some which you could, some coefficients which you could just get as ordinary regression coefficients. Now, I discussed that the theorems of statistical probability theory don't apply, and they don't. But you can quite easily, mechanically run a regression. You can run time series analysis and come up with a number. And as long as you restrict your interpretation of that this is a number to stick in, and don't try to make statistical inference about that, that's one source. The final source is that the model has to solve, right?
What you're saying now is that you can use statistical methods, you can run linear regressions, and you get a constant term out, and then you interpret that as being animal spirits. I mean, is there any?
No. That's
Okay.
not what I said. That's not what I said. It would be for the. It would. If we go back to the. Could we go back to the
Numbers?
numbers, or no, to the model somewhere? Yeah. So for example, the E sub 1 would be based. One of the sources, and I'm being no more. I'm not giving away no more than that. Could be an empirical investigation. Now, I don't believe those empirical investigations are valid in a philosophical sense that you're proving anything by it, but certainly, one is getting a number from that. People could actually extract a series for P0. My students have done this. It's a question of, again, time series econometrics. You can extract a number for P0 and see how you can get a series of P0 if you wanted. In solving a model like this, though, if we can just go, actually, this is the model. If you notice, there are some numbers which you have obtained by that, as you say, empirical method. There are some numbers which you've Googled, which you know what they are. And then you have to, if the model is to solve, i.e. to generate the growth rate, inflation rate, profit share, average real wage, real interest, which exist in the economy at that point in time, right? Then you know what the E0 term is and you know what the P0 term is, because the model has to solve, no?
Just my point of view, I mean, I know the work of John Smithon, and it's not the problem, it's like how to measure the animal spirit, as the problem is to make it available in the equation, because most of the equation of micro, they don't even look at the animal spirit thing. And then looking at the macro economic point of view and the behavior between the agents at the macroeconomic level, I mean, this is the main idea of all these equations, not the question of how to measure A0. You could measure it in the way you want, and you will get the same answer. I mean, it's not like what they found as A0 is the most accurate one. No, I don't think this is the claim they are doing.
Just to add on, but how do you, models are wonderful, but at the end of the day, we have to empirically validate this.
We're getting into deep questions of the ontology of the social world, and it's a question of what you would what do you think is empirical validation in the social world? I started my discussion by saying that one of the main problems with mainstream economics is that the main empirical method, okay, is statistical inference, the theorems of statistical probability theory. And I gather from your remark that that's what you mean by empirical validation. That's not the ultimate test of this model. The ultimate test of this model is something like abduction. What abduction would do is you would go back to the 1930s, shall we say, and run various simulations of these models, saying, oh, well, what happened in the 1930s? Was it a stock market crash? Was it a rise in interest rates? Was it any one of a number of things? And you can say, well, actually the sequence must have happened because not only did the growth rate fall, also the inflation rate went in a certain direction, also the profit share went in a certain direction, also the real wage went in a certain direction. I mean, the most simple example is that inflation and growth don't always go in the same direction in this model. Frederick is actually going to talk about some real-world examples as he goes on.
Okay, to me, it's building that equilibrium at first, then trying to change a lot of variables to see how each variable interact with each other, and what is the magnitude of it. So what we're trying to really find out is to simulate in this type of economy, if one variable change, for example, by 10%, what is the effect on the 5 exogenous variable which we see, endogenous variable which we see. And going down the list, this does explain a lot of historical debates. One of the debates is what is the relationship between inflation and growth? For example, the monetarism will tell you it works the opposite way, because when MV equal to PY, when P goes up, Y goes down. So it will get the opposite way. And with the other model, it might say, if the aggregate demand goes up, the inflation will go up. It will get the other way. What we get here is there is no relationship at all. Another one is the wage and growth. A lot of the economists predict that an increasing wage will lead to an increasing growth, just because the money are in the hands of more people, therefore creates more demand. In our model, we find that's not true. And actually, we find it the other way around in certain scenarios, which we'll discuss in the simulation in this lecture. And third one is definitely simple. It's 5 equations with the closed economy. A couple more equations with the open economies. It's very EView compatible, and it's very Excel compatible. I think I built this model on Excel in a month. Took me another 3 months to perfect it. Now with EView, I think that only took no more than a week for some reason. So we start to stick with the EView model. And also, it's an innovator. We can see how different factors react. For example, if we change animal spirit, how that affects, for example, real interest rate, how that affects the growth rate, how that affects the business profit, for example. The last one is forecasting. I remember a CEO of a company was trying to go to Turkey, but he doesn't really know what the Turkey economy is like, whether he want to move in now or later. But he does know that Turkey raises nominal interest rate quite a bit. And he started to ask me if now is a good time to enter Turkey. Enter those factors into AMM, run a model, and showed him the results. Based on these type of numbers, you make your judgment whether you want to go to Turkey or not. So that's where the real value in a business terms coming from. Trying to evaluate whether a decision is good or not. We went through these already. So I think right now I want to do a live simulation of how EView works and how AMM is done in real time, and this will be quick. For example, you have your EView screen here. It's a very simple screen. What you do is you create a new one. For work file, you can name any name you want. I name it AMN. And start date, you can have 2015. 2050, for example, the end date. And you press OK like that. So we have the equations right here, which is exactly replicate or what you guys see in the slides. So you copy that. You go new object. You run model, and of course you name it AMN. And it shows you this screen. In text, you copy and paste that here. Then you press on to equations. And you save. If it shows this screen, that means it's done. It's safe to use. If I make minor mistake here, for example, I take out the minus there. If you press the equations, it will say syntax error. That annoys me quite a bit when I first use eViews. So now make it like this. The second one, now that actually the model is complete. With eViews, it's just that simple. Now what we do is trying to input all the numbers that are from this screen right here. What you do is you're trying to type in one Gen 4.5. Oh no, Gen 8th productivity, which is 4.5, for example, like that. Then you have an A here. If you open it up, it says 4.5 all the way. Just to save a little bit of time, I'm just going to copy and paste. And going through each one like that. Did I do? Yeah. So with that, the model is actually done. If you press solve, it's going to give you give you a number. For example, with Y0, our economy is sitting at 0.03332 growth rate. Just try to open a couple more with the real interest rate with 1.9%. Inflation, we have 0.04491. So what we want to do at this point is to try to set the initial point as the equilibrium. So what we do here is trying to take all these value, equilibrium value, and enter them back into as the input. So that's what we have here. Then you press solve again. So you're going to have equilibrium all the way through in this model. So that's how we set up the initial equilibrium. And with this initial equilibrium, we can run couple simulations with that. For example, the first one we have is the increasing G, and how did that affect the 5 endogenous variables. I think, as you guys all know, in 1933, there's a big debate about whether increased spending is good or not between Keynes and Hayek. I think with this model, you can find the solution to the 100-year debate quite quickly. So, so we have our scenario here. What you do is you go to scenario, then you overwrite. You get that. So what this means is G equal to 0.3 before year 15, and equal to 0.35 after year 15. So with done, you press solve. It's going to run something called the y/1, which means y/scenario 1. So let me just show you a couple graphs. So this is how we arrived these graphs here. As predicted, the growth is going to go up. Wages also going to go up. Interest rates goes down. I mean, just kind of want to speed things through here. Interest rate goes down, profit goes down, and wage goes up. There's a question back there.
I'm sorry for interrupting again, but it seems to me you just made an extremely bold argument that your model here can help us solve one of the most fundamental questions in economics. I could come up with another model where the effect of an increase in government expenditure had the opposite effect. And I could claim exactly what you just claimed, that now we have the answer. So can you tell me what is the reasoning behind the argument that this model here, based on a simulation, for me, it seems a lot of arbitrary parameters that we can solve such a fundamental question so easily. I just don't get it. Sorry.
Yeah, I mean, again, I think obviously what we're doing is we're kind of showing you the model in its final form, if you like.
Yeah.
And the rest, I mean, we have not explained the theory behind it.
Yeah.
You know, and I mean, I think that's fair comment. I think that's fair comment. I think all these comments are fair on that basis. But what we're going to do once I mean, at the moment, Frederick is showing how to use the software, right? When we return, actually, we are going to have to break in 5 minutes because the food is ready now.
Okay.
So we'll do another 5 minutes, and then what we need to do is precisely go back and talk about, you know, money, theory of interest rates, you know, all those things which are implicit in this model. I mean, yes, I mean, at the moment we've just written down the model, but the model hasn't been arrived at with no prior thought.
So hopefully at the end of the course, I don't need to ask the question.
Exactly. I mean, what we're doing is we're showing the output before we've got to the, you know, where.
I get it.
Yeah.
We keep having the same question.
Yeah.
That's the question, how to look at the theory behind that.
Yeah. That's exactly what. But it's useful. It's useful to do that. I mean, the other question about, you know, well, why don't we just increase government spending to like 9,000%? Interesting question. You know. But I mean, but there is an answer to it. You know what I mean? But we have to kind of talk ourselves through it, so to speak. So do you want to do the break now then? Are you all right?
I'm fine. I'm fine.
Yeah. So
I think the others are coming out of the room.
Yeah. So we'll do the break. We started late, remember? So we'll do the break now, and then we'll sort of get back on track,
And then continue a bit later.
and then maybe continue a bit later. You know, after the lunch.